Why spend time on cosmic pictures if humans won't live long enough to touch the boundaries? Witness the mother black hole, or watch the universe return to sea. In the energy filament theory, the answer is that these far-end questions are not just poetry. They are stress tests, and stress tests are how you find out whether a framework is real or just a clever patchwork. Lay the whole set of views on one map and you see a single continuous chain, an early energy sea that boils and mixes. Particles as stable filament rings, light as a relay rather than a bullet. Four forces as one medium responding in different modes. Cosmic evolution as relaxation rather than expansion. The modern universe as zoned by tension windows. A real boundary where relay fails. Black holes as the too tight extreme. Silent cavity as the too loose extreme. A mother black hole that overflows into an energy sea. And a long endgame where the responsive universe narrows like a retreating tide. You don't have to agree with the conclusion first. The real question is simpler: can one mechanism keep the accounts balanced from micro to cosmic without inventing a new special rule every time a new phenomenon appears? That leads to the first reason people study these pictures, and yes, it's philosophical. The future of the universe may not change tomorrow's breakfast, but the drive to know is part of what makes us human. We don't only build shelters, we build maps. But the more important reason is physical self-consistency. A candidate unifying framework must survive the places where patchwork usually breaks, the extremes, the boundaries, and the long-range closures. If a theory explains only the comfortable middle, it can always sound plausible. The real test is whether it can walk into the corners without changing its language. That is why this project keeps returning to a small set of core assumptions and trying to stretch them as far as they can go. An energy sea, tension, texture, and particles as filament rings. From that base, you try to derive stability of atoms. Emergence of matter, why redshifts and temperature history might be misread. Why black holes and cosmic boundaries behave like mirrored extremes. And why a silent cavity becomes a natural opposite extreme. This is not to make a prettier story. It is robustness testing. The more a framework tries to explain with one mechanism, the more any wrong premise will be amplified, and the sooner you'll be forced to add patches. That pressure is exactly where mainstream cosmology has struggled in public view. Once you lock redshift and background cooling into pure geometry, when the explanation strains, the typical move is to add new ingredients to keep the closure. Inflation for early puzzles, dark energy for late-time acceleration. More parameters to keep the fit stable. That approach may fit the data very well. But fits data is not the same as is the only story. And it is not the same as is the closest mechanism. This is where Occam's razor stops being a slogan and becomes a selection tool. A framework that assumes fewer new entities and yet touches more phenomena deserves careful attention, even if it later turns out to be incomplete. For example, using the to-face. The effect of short-lived particles to address both extra gravity appearance and a diffuse noise floor is a way of testing whether known unstable behavior, already confirmed in laboratories, can carry more of the cosmic bookkeeping without introducing a brand new invisible substance as the first move. That doesn't declare the mainstream wrong. It declares a principle. Try to minimize new assumptions, and see how far one mechanism can go before it snaps. And that is why boundaries, origins, and ends are worth discussing. They are the finish line of the stress test. They force you to write down what happens in extreme conditions, what happens when relay fails, and whether the story closes without hand-waving. Even if we never prove the boundary by traveling to it, a good framework should still leave hard, testable knots, fingerprints, and predictions that observations can look for. In this picture, these episodes are not a verdict. They are an open, unified framework trial, run in public, where the evidence is the only judge. Tap follow, share it on New Physics, Clear Universe.